About me, so Jérôme, I'm CMO at Alsid, so I'm Chief Marketing Officer. I can read your minds right now. You're thinking like they threw at us a marketing person. That's going to be awful. You're partially right, but I have a pretty technical background anyway. I've joined the evil of marketing a few years ago, but I definitely come from the technical part of things. So I still know a couple of things. Apart from that, that's it. I've done only security in my life, so nothing else very significant to discuss. One wife, 2 kids, that kind of stuff. I'm gonna be here talking about AI in the context of cybersecurity. So that is not going to be a deep technical presentation of AI. It's going to be AI in the context of cybersecurity, how it is used, but more importantly, how is it going to be used in the future. So I'm going to use a timeline. So I'm going to go, what are we doing now with AI in cybersecurity? What are we going to do in 2020, 2022, etc. Of course, this is out of my crystal ball, so it's not meant to be absolutely precise. When I say something's going to happen in 2022, please don't take it literally. It might happen a little earlier or a little later. It doesn't really matter. But the order of those steps, I think, are pretty accurate, or at least I hope so. So let's get started. Of course, yeah, well, are you familiar with the buzzword bingo? That's a great game you should play at your company as well. So there's going to be a lot of buzzwords. AI, for one, is a buzzword. I'm going to talk machine learning, etc. So but please indulge me. So AI in cybersecurity. First of all, this is not a greenfield space. It is super hyped, and we have tangible evidences of this. Those data, of course, don't come from Alsid per se, but from analysts. And so you can see that the fundraising for AI in cybersecurity is pretty high already. So that is 2 years old, but you can see a big trend in there. And there are startups. Some of them are bigger than startups. CrowdStrike announced that they were going to go through an IPO process just last week, I think, and they're doing like 250 million dollars of revenue. So big companies in there. Darktrace as well is well over 1 billion euros of valuation. To what extent they do AI is still to be seen. Like, they are doing things. What are they doing is another story. So then we can talk about that there. Oh yeah, that was my animation. So the reason why AI is really hyped, I can definitely see 2 reasons. There's an actual reason. It's pretty useful. In the context of cybersecurity, we have a big data problem. Big data is a great thing for many aspects, but it's also a problem. Before we add the actual big data definition and all the technologies that go with it, we in security had a problem of massive amount of data that was poorly processed by automated systems. So you had in companies people who were in the security operations centers. So think about it's a CCTV system, basically people standing in front of screens and saying what's going wrong in my company, and they basically had too many data to process. So correlation existed. We had the SIEM technology in place, but it was still very preliminary in terms of volume, data processing at scale, I'd say. And so a lot of incidents were actually not treated, were going under the radar just because the people were not capable of processing all this data. So there's definitely a big data issue, and AI and cybersecurity and big data goes hand in hand together. A quick, maybe very quick and very simplistic definition of what is AI. So AI is really about, I gotta play it again. My robot, I love it. So AI is this, like an actual machine that can think by itself. I don't know any AI except in those movies. I don't think we have any AI today. We usually, when we talk about AI, we actually talk about narrow AI. So we talk about limited systems that can programmatically I'd say, mimic and imitate what we humans are doing. This is not a full-blown self-replicating, self-learning system, etc., which is past the point of singularity. Not today, and probably not for a few years. What we have, though, is pretty mature now machine learning algorithms or concepts. Machine learning is basically algorithms that can teach themselves, that can learn how to process data in order to get a result. If I compare that to a programmatic approach, basically if I can write a program that says, here's an input, this animal has 2 legs, that's a human. If it has 2 legs, that's a human. If it has 4 legs, that's a cat. That would be a very simple program I can write, which is not machine learning, obviously. What I would do as a machine learning programmer is I would take a program that basically doesn't know what is a human or a cat. It doesn't know those triggers like 4 and 2, but I'm going to provide that program with a lot of data that says, here's an input, and it's a human, right? So we call that labeled or labeled data. Well, I'm not going to go into that space, but let's say you tell him this is a human. It has 2 legs, that's a human. This is a cat. It has 4 legs, that's a cat, etc., etc. And you do this a significant number of times, and at some point you will be capable of providing an input without telling whether it's a cat or a human to the machine, and the machine is going to say, I can see the pattern that I had before. This is a cat, and I can see it has 4 legs. The advantage, of course, my example is pretty trivial, but the obvious advantage of that approach against versus a programmatic approach is that if tomorrow half the population is crippled and we only have one leg, basically I will have to go to my program and change my triggers and say, oh, if it has 2 legs or if it has 1 leg, then it's a human. With the machine learning approach, I can just continuously provide samples to my algorithm that says, well, that's 1 leg, by the way, it's a human. Take it. That's 2 legs, by the way, it's a human, etc., etc. And the program will adapt itself and understand from the samples that I'm providing to train it that actually, if I provide something with 1 or 2 legs, it might be human. I don't need to change the program. The program adapts itself to the task. Then you have deep learning. Deep learning essentially is the same concept, though we use deep neural networks for it. So it's a layered system, and I'm not going to go too deep on that, but think about anything that is, my previous example is a discrete example. It's pretty easy, 2 legs, 1 leg, 4 legs, 1 cat. If you want to do something that is not discrete, that is continuous data, if you want to analyze a picture, if you want to analyze a voice, a speech, a text, etc., then you have something that is a flow of information that is not discrete. And basically, if you want to go to that level of precision, to that level of detail, you need to go to deep learning. It is not more complex, it's behind the scene, it is more complex, but in today's implementation, it is not. We have a lot of frameworks. If you use TensorFlow, for example, at Google, switching from a machine learning algorithm to a deep learning algorithm is pretty easy. So think about deep learning as a more advanced version of, it's a subset of machine learning, and it's a more advanced version of machine learning that can analyze something with a way thinner granularity. At the expense, of course, of performance. So what machine learning you could run on a computer, deep learning today you can't, right? You need to have a cloud infrastructure or a server that is going to dedicate a significant amount of resources for this. There are a very known example of those applications like Siri, not Cortana anymore, but the Alexa, etc. All the language processing software that you have. We have a resolution issue. This is about cybersecurity. So I don't know how much you know about cybersecurity, so indulge me into providing you a short introduction. So maybe the easiest way would be to go there. No, temporal. Okay. So we have two concepts, right? Two dimensions. I'm going to talk about defense, and what you can't see there is offense. So attacking side, defending side. Of course, the model I use here is very simplistic. So if you are a security specialist, just don't throw any stone at me. But basically, when you do security, you do four things, 3 or 4, depending on how you modelize this. You anticipate threats, so things that have not happened yet. You need to understand what kind of threat you are facing, so that you can adapt your defense tactics. Think about a real life. You can't have a policeman in each street. So what are you doing? You are using intelligence in the sense of information gathering, not being smart. So you are going to use intelligence as a means to understand where are the bad guys living, where are they working, how do they come to the city, etc. And so you're going to end up with 100 policemen in the railway station and probably no policemen at all in many streets. So you use information you gather from your adversary in order to adapt your defense tactics. Prevention would be based on this, like once you've informed your tactics, then you need to harden your infrastructure. So differentiate that from the detection. Detection is something bad has happened, now I need to detect it, I need to be aware of it. Prevention is more, well, before something happens, I'm going to put steel on my door, I'm going to close my windows, etc. So you limit your exposition to the threat. You're not yet at the point of detecting it. When you've done prevention, then of course someone's gonna break in for sure. So you need to detect that. So you have special capabilities. Most of the startups that were funding AI security in one of those previous slides were in the detection realm. And then response, because at some point you will detect something, you need to respond to it. So think about a SWAT team. You basically drop a team with tools so a team of people armed with tools. And what they're going to do is try to contain the attack and then mitigate, remediate, respond. Possibly, if you are in the nation-state realm, you might retaliate, but that's a different story. On the offense, there are very known frameworks for modelizing. 5 minutes? Well, I'm gonna go faster. So what you do is reconnaissance, so kind of the same thing in anticipation. What is the characteristics of your future victims, so that you can tailor you can craft the perfect attack for them. Primal infection, I'm going to get a foothold in your company, one computer. I'm going to have my malware in your computer, which means it's going to be my computer eventually. And from there, I'm going to remote control. It's usually human driven process. I'm going to use that as my remote control system, so that I'm going to explore your network and start moving laterally inside your network. Evasion is the techniques of avoiding detection, and exploration is what I meant. Once you have a one foothold, it's very unusual that you have access to the vital assets that you are targeting, whether it is data or I don't know, some physical device or whatever. So you need to move laterally inside the organization until you reach the vital assets that you are looking for. This is the framework I'm going to use for talking about AI. So now I'm going to try to map. I'm going to try to map what I think exists or will exist when it comes to artificial intelligence for security, cybersecurity. So what's in orange is about proof of concept. So we know that we have research papers, we have proof of concepts, we have experiments that prove that this is possible and it has been implemented. What's in green means it is in production. So if it's defense, it means it's in production in actual products. If it's in the bad guy side of the slide, then it means we have seen it in the wild. So someone is actually exploiting them. So in anticipation, we have already pretty good tools, but I wouldn't say they are product, that are used to gather information about your hackers. So today you have a whole industry which is called cyber threat intelligence, shouldn't cross that on your buzzword bingo. So cyber threat intelligence basically is a practice of studying how your adversaries are behaving. And to do this, you go on cyber criminal forums, etc. You are reading their conversations. You are engaging with them, actually talking to them sometimes, etc., etc. You are reading papers. When CrowdStrike, when FireEye, when whoever publishes, like the ANSI, whatever, publishes a paper that says, here's the analysis of APT 28 or Korean, whatever, then you need to read it and actually extract information for it. They are contextual information, when, how, what are the tactics, etc., and they are technical information, IPs, hashes, etc., in those papers. You need to read them, extract that information, and use it in your threat intelligence system so that you inform your detection. Well, this is something, obviously, AI and machine learning, deep learning is really good at. Take this unstructured information in the form of text, and sometimes with the lingo of a Russian-speaking cyber criminal in a shady forum, and you need to extract valuable information and actually modelize it in a technical language that can be used by a machine later. And that exists as a proof of concept. In terms of detection, we do have companies, so notably those that were founded recently, and Darktrace is definitely the leader in there, that are using machine learning. So they're saying they're using artificial intelligence. Granted, I haven't seen their source code. Or granted, I probably wouldn't be capable of putting the artificial intelligence part of it because it's too big and I wouldn't have the time. But I'm pretty sure they don't do artificial intelligence the way they'd like to advertise it. But they are truly doing machine learning the real way. They are doing machine learning, it's pretty efficient. The tests that are doing in a black box environment are pretty good. Machine learning for prioritizing incidents, I'm not going to go through that today, being mindful of time. Like I said, too many events in a security operations center, you need to understand which of them should be your priority as an incident responder or as an analyst. Basically, machine learning can process a vast amount of data and you can't, so that they can say, well, out of the 100 incidents that occurred yesterday, here are the 10 you should investigate. And don't take that wrong. It's not about saying there are 100 incidents, but maybe only 10 are true incidents and the rest are false positives. It's bigger than that. It's more like you are an aerospace company. You are hacked on a weekly basis by nation-state sponsored hackers, Chinese, US, whatever, and which are trying to steal your secrets, right? You have those incidents. Hopefully, you have them in your monitoring system. But you also have incidents about what a banking malware that just ended up on my computer as an employee of that company. It's a banking malware that is trying to steal my money, personal money, when I log into my bank account. Well, from this aerospace company perspective, this is not a priority. This is bad. At some point, it should be remediated. But this shouldn't end up in the top of the pile of the 100 threats that these people are looking every day. So machine learning, understanding deeply with nuances what is important, what is not from a security perspective, it's pretty close one. On the offensive side, nothing truly is implemented. We have proof of concept. So one which is really cool on the reconnaissance and side of things. So you're all aware about phishing, right? I send you an email, click here, and you get infected. Kind of a shortcut, but that's okay. I send you a tweet, a direct message on Twitter, you click, infected. What? You downloaded something, you get infected. So there's a Forbes journalist like 3 years ago, so it is not exactly yesterday. He had you couldn't call that a scientific experiment, it's just an experiment, a fun experiment. He actually ran a contest against an AI that was trying to craft phishing tweets. All right. So what they did, they took 2 hours, and in 2 hours they had to send as many tweets with a link that was malicious, supposedly malicious. In truth, it was just a harmless web page, and see how many people actually clicked on it. So the journalist he prepped himself up. Like first he says he was sure to win, and so he had like a sample of a few texts he was going to send, just adapted very quickly, looking at the profile of the person he's gonna try to reach, and adapt it, push it, etc. Something you think only a human would do, and so he made that context. The results are pretty staggering. So of course. He sent something like 129 tweets over the course of 2 hours, so a little more than one per minute. It's not bad considering you have to investigate, right? And the AI sent about 800 something tweets. This is not unexpected, right? It's a machine, you expect it to be just faster. What you would expect though is that the conversion rate, the number of people who actually click proportionally would be way lesser for the machine than for the human. It wasn't. So it was in the same ballpark, maybe 1 or 2% of difference. But very much the same kind of performance, considering it's one single test. And the reason is, of course, we are better trained at recognizing patterns instinctively, etc. This is not going to work. But the machine was capable of drilling into the profile of the person way deeper, so that it could craft messages that were more in line with what those people were saying. It was also capable of localizing the messages in a nanosecond, which was an unfair advantage, but who cares? So, primary infection, same thing. You get deep learning, you design handcrafted phishing campaigns. Evasion, what did I write? Oh yeah, there's one which is, I think it's going to remain a potentiality, but not a true thing. It's how you tamper with the training data that is fed to the AI system. The AI is as good as your sample you provide it with when you teach it. Like if you give 8 legs and you say it's a human, in my previous example, that's not going to work at something. So you can tamper with those data and actually corrupt the AI that way. I think. So I wanted to mention it because it is not unseen that security editors, security vendors, notably antivirus editors, get hacked and their source code be tampered with. It existed. Only last week, or 2 weeks ago, Simon Tech admitted that they got breached and someone accessed their source code. RSA got breached 8 years ago, etc. So it happened. I don't mean to say it's a huge threat here, but it happened. On the evasion, of course, cat and mouse game, that's cybersecurity. So we design models, we design machine learning systems to detect people, and then they design something that knows how to blend into those models. So all models basically are saying, this is clustering data. Out of the million events that happens in a company, I'm saying, those are normal, those are suspicious, those are critical. The machine learning system, deep learning system, can basically create clusters of profiles like this. If you are capable of understanding the model so that you actually look like being part of a normal cluster, then you go through. And there are actual research papers and actual examples and implementation, but there are still proof of concepts of this, including for non-security things like you train, there's a very famous example when you train an AI to recognize a panda, for example, and you just add a layer of noise from visual perspective to that image. From a human, it's just undetectable, so you still see a panda, good for us. Well, for the AI, it's completely disruptive. And suddenly it doesn't see a panda, it's I can't remember, a safe or something. 2020, moving forward, the green, just saying those things are going to be industrialized, to come into play. So no more description of this. The bottom right thing. Today, it is wrong to think that attacks are on autopilot. It is not, I drop an executable malware on your computer, and this malware is going to explore and to find things and etc. and do something, live its life, and then exfiltrate that. No. The first thing that malware does is it calls home. It says to the hacker, "Hey, guy, I'm installed. Like, what do we do now?" So it's a toolkit. There are tools in there that the guy can, or the gal can activate remotely, but it still requires remote control. And so we have a couple of examples of old malwares, actually in 2009, for example, with Stuxnet, of malwares that were able to work their life autonomously, but that was programmatically created. So it was scripted. If you see this, you do that. If you see this, you do that. And the depth of those scripts were impressive. It was a real advancement in terms of attack at the time, but it was not at all an autonomous system. Now we're going to see this. We're going to see actual malwares capable of understanding what's the least path of resistance to move from my primal infection to the vital assets I need to corrupt. They're going to do that by themselves, and that's going to be interesting. What else? Yeah, and that's important as well for air-gapped environment. A lot of critical infrastructure maintain an air-gapped network, meaning it is not connected to internet, and it's hard to hack them, and this is a solution. I got it. One slide I want to talk about, and then I'll leave you alone. My point is, where you are, unfortunately, we are going to see a big rise of AI in cybersecurity. Will be on the offensive side when those two worlds will meet. This is a BCG paper. They say 2018. They had the same crystal ball I did, I guess. But the point is, today in today's threat landscape, most of the malwares that you can see actually are coming from a toolkit. They are not developed by the actual hackers that is using them. They buy a toolkit, they adapt it, and then they use it. For AI, you had companies doing AI, and now you have companies that are doing productized AI, TensorFlow, etc. You can use them yourself, web-based, it's pretty easy. Those two worlds are going to collide at some point. And the people who are doing tools, I can't see any hacker doing himself or herself the AI things, too much loss of time, too complex. But someone who's capable of building an efficient toolkit today will be capable of doing a toolkit that includes AI capabilities. And so when those toolkits will be available, which is in 2022, like I said, then everything in there will turn green. And then we'll go back to the old game of adversarial training for us defenders. That will be cat and mouse all over again. That's the last one. Meaning they will improve their AI, we will improve their AI. Very likely defenders' AI will be better, though they have the asymmetric advantage of we need to defend anytime, anywhere, and they just need one attempt that succeeds to win. So that's it.
Thank you, Jérôme. You are passionate about the topic. We're going to have just a couple of questions because we are running behind time. So, who's going to ask the first one? Yes.
Hi.
Okay.
When you want to protect an AI system from cyber attack, you need to protect your database, sample, and everything, and also your models, the neural networks. Which one is the most important and the hardest to protect?
Oh, I think it's your sample, your training data. So that's something I didn't mention. Like I really took AI as a tool in cybersecurity. There's a whole realm that is also AI in cybersecurity. It's how people will be capable of exploiting AI for talk recognition, etc., speech recognition, etc., in order to do something else. That's your point. So people need to protect their AI, even if it's not related to security. And I think I don't have a definitive answer, but that's the sample is the most important. And why? It's because that's the part where it's going to be very difficult to see that it's been tampered with. It's so big. Almost by definition, you don't have statistics on it. It's unstructured. That's the way you want it. So if someone tampers with the data, you're going to be in trouble seeing it. It might actually go unnoticed for years before you see it. So I would say the training data.
I have a question regarding the marketing side. So, for your point of view, who is the best? What is the best position to train this algorithm and to it's all about having the right data. So you are in the sweet spot for the Active Directory, but Splunk or Datadogs or all these big companies who monitor tera of data every day. Everyone would like to protect and provide more and more added value on the top of their software. Do you have any thinking about that?
First of all, I think, there is no secret that I think Splunk wants to play a big part in security. I think all the actors in that realm, including open source players, will want to play a part in that game. So I think I don't want to name any names, but I think that's going to be a hard market if you talk about marketing, because those players, which are very powerful, they will develop their own stack of protecting their data and protecting their AI, and they will provide AI out of the box as a part of their cybersecurity layer out of Splunk, for example, or others. So from a market perspective, you gotta, the differentiator need to be very, very, very important. And that's where, from a marketing perspective, it's hard, because I can see the threat, not from a cybersecurity perspective, but I still have nightmares about the era when we said we have an antivirus, it protects 101% of the threat possible, etc. And you had, at the time, no possibility of actually testing this. It was very hard to test what was in that black box. The only samples you had them by the antivirus vendors. It was almost impossible to test it, and I think we're going to go back in that kind of era with AI. Very few people are going to be capable of actually testing what it's doing in real life. So we'll have differentiating will be very hard, I think.
One last question.
Regarding accountability, because now we have AIs and so on, but nobody knows exactly how it works, and nobody is capable of mathematically proving how it achieves the results we are seeing. And from a legal point of view and from a technical point of view, is that a concern for you as a cybersecurity company? And how would it impact your daily jobs?
So, yes, the ethical/legal aspect of it is a concern, though, to be honest, other people are going to have that concern very, very, very earlier than us. Like, countries are discussing whether a AI-powered system can actually pull the trigger, an actual trigger, with a bullet going through a rifle and ending in someone's skull. So they're going to have that legal issue before us. Self-driving cars, they're going to have that legal issue as well. So yes, it's a concern, but to be honest, I think when AI will be in a place where it can trigger actual actions and do something that might be harmful, those things will have been sorted already from a legal perspective.
Okay, thank you.
Thank you, Jérôme. Let's move on.
Thank you.